Welcome everyone to lesson 4. In this lesson, we are going to talk about security on layer 2, so basically on switch layer. Then we talk about basic routing, and then all the dynamic routing protocols that exist. So for example, routing RIP, OSPF, IRGP, and BGP. These are the most common routing protocols that are used. So if you think about a switch, it's cool, you plug it in and it will work. But sometimes you have people that have like less good intentions and they might want to sniff your traffic. And that's why it's very important to enable certain security measures on your switch. What's also very important is to remember important insecure. It's also important to recognize insecure network designs. So if you see a network like, oh, that's insecure, so you know how to fix it. That's very important to know. It may be also possible for someone to prevent a loop in your network, breaking your whole network infrastructure with one cable that's being plugged in double. Or even worse, get access to your VLAN database, which they can use to map your network. So what do you do for security on layer 2? So first of all, you're going to enable spanning tree BPDU guard. This basically switches to communicate with each other by means of the bridge protocol data units. For example, this contains the STP message. Do you want a switch or a certain interface not to receive a BGP message? So this basically prevents these messages from being sent over the network. The second thing you want to enable is spanning tree root guard. That means only one switch will be the root switch. So no other switch can take over the role of all the other switches in the network. And then the last point I want to talk about is switch port mode access. This way you cannot just plug in another switch and make it auto sensing, so it detects a trunk port, so we can send all the VLANs over the switch basically. Yeah, we want to prevent that, so that's why we use switch mode access. A few other important commands is if you want to enable port security, you first have to switch port mode access. You can also decide, okay, we have port security, but we only want one MAC address or one computer to be on that port. That's why we use port security, and in this case we put it to a maximum of 1. And that's also an option, like usually you put in the MAC address manually, and that's a lot of manual labor. So there's also an option to put in sticky, which allows the MAC address to be learned and will then put in the port security table. Let's show how this works in practice. We have our packet tracer right here. And let's see how port security works, guys. So we got this switch here, we got a computer. And if we look in here, it has an IP address of 192.168.1.2, and the other one has an IP address of 192.168.1.3. So what do we do if you want to enable port security? What we basically do is type enable config t from there we're gonna use the commands I just showed you guys. So we do interface, and then we select the interface we're on. We don't know that currently, so we hover over it, and it says F802. So we do interface F802, and from there we type in switch port mode access, and we type in switch port security, and from there we also do switch port security MAC address sticky, and we go and exit. So if anyone else besides the computer with this MAC address, this IPv6 address, I'm sorry, this MAC address, this MAC address, sorry, somebody else with not that MAC address is not able to get on the network anymore. So they need to have this specific MAC address to access the device. If any other MAC address gets detected, the port will get shut down. Any questions so far? No questions? Okay, let's continue. So this was a demo for port security. Let me get back on my presentation. So we already covered the security stuff. We want to go a little bit back more in basic routing. So we already saw in the previous lessons how to do routing, but to make it easier for you guys, I have gave you guys some commands you can use to build a static route using the Cisco CLI. So you type in IP route, then the network you're trying to reach, then the subnet mask, and where can I find this router's IP. So example, IP route, the network we want to find, we want to go to, the subnet mask, then the location where I can find this router or this network, where he needs to ask where it needs to be. If you want to troubleshoot this connection, we can use ping. That's an easy way to check if something is reachable over the internet. It basically uses the IMCP protocol, the Internet Control Message Protocol, with an AGO request to specify an interface on network and wait for a reply. So it gets sent and you get a reply back. And the second command you can use is tracer. This allows you to trace all the hops that you're moving over to reach your destination. This can be very useful if you want to track or trace what path or your packets will take. Now we covered the static routing part. We already had a demo for that. If you are missing out on the previous lesson, it's online for this last day, I believe, and it was previous. We at least have the slides online, so you can definitely watch those back. But we get into a dilemma. Our company is growing rapidly, and we got all these routers, and configuring them with static routes is just so much work. So this is basically where dynamic routing protocols have been invented for. These dynamic routing protocols can uh, these dynamic routing protocols are basically divided in three categories. So you have distant vector routing, link state routing, and hybrid routing. Under distant vector routing, or RIP, like we called before RIP with V2, they basically do best path calculations based on the number of hops. So the less hops, the easier it is for RIP to choose that connection. For link state routing, they also uh, take into account how much work it is for the router to move over the data. Not only do they do a hop calculation, but they also make sure that it takes as little as effort as possible to send the message over the line. For hybrid routing, that's IRGP, is basically to eliminate the negative access. For example, EHP was developed by Cisco and has advanced over the distant vector routing protocol. So in terms of CPU power, it's less CPU intensive. So here you can see how these dynamic routing protocols are divided. So you have the interior gateway protocols here, then distant vector routing, RIP2, RIP1, IRGP and IRGP, then link state routing protocols, OSPF and ISS. We're not going to cover this one because it's not that used that often. And then you have the exterior gateway protocols. So those are path vector routing protocols, which includes BGP. And BGP is a very complicated protocol. We're not going into it too much depth because it can be really confusing and hard to understand. So I try to keep it as bare bones as possible. Did I already cover this? Yeah, we already covered this. Or we didn't, but yeah, just read this slide. Yeah. Okay. Yeah, this is another important picture is the difference between each. So down below you see OSPF, ISS, RIP, IRGP, and BGP. And it also shows which algorithms it uses, like the Dijkstra shortest path, Bellman for shortest path, or local policy to rank path. And you can also see how they do the dissemination. For example, OSPF has a flood link state advertisement to all its routers. BIP and IRGP update distances from neighbor distances. And for BGP, it updates path based on neighbor paths. For Converge, fast due flooding. For RIP and IRGP, slow due to the count to infinity. And path to factor slow due to path to exploration. So let's start with the first one, and that's called the Routing Internet Protocol. The first version of RIP was only classical routing, broadcasts the message less efficiently, and the router has no authentication. And if you have no authentication, anyone can steal your routes or modify them. This is also what we mean by security. Have authentication. Make sure your systems have these passwords in place to prevent unauthorized access. For RIP version 2, it supports subnets and also multicast routing messages, and RIP next generation is just extra added IPv6 support. So how do we configure RIP? So it's basically you type in enable config t router rip the networks you want to connect to, and to enable P2. So you just type in version 2. If you're curious, okay, but I just entered all of this, but how does this look on my router? You type in IP route. IP route will also show you the uh, administrative distance, and this value basically shows you, okay, how much effort is it to go over each link, and how higher the number, how easier it is to choose, basically. So if it's lower, it's less likely to be chosen, basically. Okay, there are some other important commands. You can set the interface to passive. It receives all the RIP messages but does not broadcast anything itself. You can put the distance yourself. If you want to customize that for some reason, you could. And you can also use the command default information originate. It basically updates all the routes involved on the network with a new routing table. So it basically just sends an update on, hey guys, copy this new routing table. So we talk with all the new routers that have been added to the routing table, basically. So here's an example of a simple network. So here we have these 4 networks. And if you want to do rip routing, basically, you enter those commands on each router and just make sure they're all added to the routing table. And you should be able to route to every single network. The next protocol we're going to talk about is IRGP, Enhanced Interior Gateway Routing Protocol. It's an advanced
Hello?
distance vector protocol. It uses dual as an algorithm. Characteristic of IRGP, it works with an autonomous system. These areas that you define yourself, where all the routers share a routing table. So that in that like is the IRGP and RIP are like almost in like the same ballpark. Um, An attempt is also made to calculate an alternative path for each path. So basically, if one router gets destroyed, the IRGP makes sure there's another route to route their traffic over. So that's basically the failover protocols. IRGP is also able to load balance its traffic over 2 different connections. OSPF, the protocol we're going to talk about soon, is not able to do this. How do we configure IRGP? Enable config T router IRGP1. Type in your network with the, not sure what this was, but just type in the network. You can use the troubleshooting commands like show IRGP interfaces, show IP IRGP neighbors. Other commands you can use with passive interfaces, so it's the same for RIP. So it basically allows you to send the commands without actually doing anything with them. So it's passive. Then we have OSPF. This protocol basically works with areas. I'm gonna show it in the next slide soon. But it's important to remember that there are some terms you need to know. For example, you have like DR and PDR. So the designated router, DR, and a backup designated router. They basically all have the same routing table. But it's important to remember that you know it works with zones. And of course, OSPF will load balance the traffic over the connections. That's also important to remember. In addition to backbone areas or normal areas, it's recommended to, or this guideline is a maximum of 50 routers in one area. So for one area, you can have 50 routers connected to one area. Did I just copy this page? Yeah, that's my bad. But you can see the, and there's also the ABR, the area border router. And that one basically has access to one or more, or like two or then more zones basically. How do you configure OSPF? It's pretty simple. You just type in enable config t, router OSPF1, type in the network with the area, and then you, to show the OSPF configuration, you just show IP OSPF. And here you can see an example for an IRGP or an OSPF network. Shouldn't be that hard, but here you can see is the area 0. And this is like the border gateway router then, because it has the access to the next area, as you can see. Very easy. The last one I'm going to talk about is the border gateway protocol, and that one is actually most used in internet right now. And that's also another autonomous system. How to configure BGP? Like BGP is a lot more complicated because you have a lot more commands you have to enter. But this is a way you should be able to configure it. Yeah, we're not going into too much detail because this is out of the scope of my class. Yeah, let's make a network, guys. We're gonna use the previous network we already had to show the rip routing. Let me get the packet tracer. Okay, guys, we're right here. Any questions so far? No questions? Okay, let's continue. So what we're first going to do is enable. Oh, my bad. Enable config t. We need to know the interface, so we're going to put this on top. Look for the interface. It says gig 00, so we do interface gig 00. And then we type in node shutdown, IP address 192.168.178.1. Oh, you need to set a mask, guys. Put in your setup mask. Let's also configure the other side. So we do exit, interface, serial. I believe it's 0100. Let me just check. Oh, it's 3, my bad. And then we're gonna do a no shutdown. From here, we're going to set the. Hold on, guys. I have to get the commands again. Oh yeah, clock rate. Oh, okay. They type in clock rate. Rate 9600. Okay. And then we're gonna set the IP address again. So IP address 192.168.179.0. Oh, double one, my bad. Then set the mask. And then we do exit. And we're basically going to do all the same commands on this one. So we do enable.
Yeah. Yo, that's okay. Fish. Nee. No. Yes. Oh.
Let's continue, guys. Okay, router 1. So config T, config T. Then we do interface gig. No, serial. We do serial first. 0 3 0 3 0. No shutdown. Log rate 9600. There. Okay, there we go. We should be able to ping and go to exit, ping 192. Wait, ping. Is that a command? It should be. Oh, yeah, we forgot to set the interface. My bad. Let's set the interface for that. And we do interface. Go for serial this time again. 0 3 0 0. IP address 192 168 168 179 2 255 255 250. There we go. And we should be able to send a message between them now. And it says successful. Great. Let's configure this real quick. Alright, this already been sent. Great. Okay, let's see if we can do this one. Enable, Ctrl+C, interface, gig, 0/0. Enable, oh, no, not shut down, I'm sorry. There you go, our link goes up. IP address 192.80.1, 205.25250. That will be our gateway. We type in exit. Now we want to configure this last interface on the right side. So SO3's 1. Let me just do arrow up, it's probably the easiest. And now we do no shutdown. And we follow that up with block rate 9600. That's fine. Then we type in IP address 192.168.81.1. Oh, and set a map. You have to, of course, type in IP address correctly. There you go. Then we configured this router. Then we are going to do it on this side. Enable, config-t, no shutdown. Oh, interface, interface, serial. Let's see which one. 01, 031. And then we type in no shutdown. Our link goes up. Plug rate 9600. IP address 196.81.2. And you have to type in the setup mask again. Okay. Then we do the last interface. So we do fast gigabit interface with Ethernet 0/0. No shutdown. Okay, let's go. It goes up. From here we do IP address 192.182.1. Make sure you spell IP address correctly, guys. IP address, there we go. There we go. And now we type in 1 to the mask. There we go. And then we should have an almost functioning network. Let's check all the computers right here. If they have been configured correctly, they haven't. So we type in the default gateway, guys. Make sure our devices are on the network. Check this one. Nope, not assigned. Okay, now our machines have the IP address. Now they do. And we're basically, instead of setting up the static route, we are going to set up the rib routing. That's like the big difference from lesson 2. Is everyone still there? What's going on? Hey, B7H30. What's up, man? Welcome to the stream. Yeah, let's configure the rip routing, guys. Let's get the slides ready. Rip routing. So that's actually pretty easy. So we go back in the router, enable config router rip. Then we type in network 192.168. .179.0 192.168.179.0 network 192.168.170.80. I'm just gonna add them all just in case. 81. I type in that it's easy to copy paste this probably, but we type it in for good measure. Okay, so we typed in all the networks. Let me get my notes back. So we also want to enable v2, so we do version 2, and then we do exit. So we basically do the same on the other 2 routers. So we just pin this. Enable. Oh, we're already in config modus. Router rip. Network 192.168.0. Network 192.168.179.0. Network 192.168.80.0. Network 192.168. It's a little bit repetitive work, but normally you make this a copy paste basically and just slap it in. But it's good practice, guys. And now we do version 2. Exit. And we will do that for the last router as well. Router 2. enable config t router rep network 192.168.178.0 network 192.168.179 192.168.180 0 192.168.181 and the last one 181.0. Yep, me too. And now we do version 2. Okay, we do exit. And let's see if our network actually works. I highly doubt it, but it never works the first time. Or the second time. Let's see if the interfaces are set correctly, guys. That's why we see the problem. The clock rate is so messed up over here. Not sure why. I forgot to set it probably. Clock rate. Yeah, okay, it's set right there. Yeah, and there we go. We got a successful, guys. Yeah, this is basically how you set up routing, guys. We used the previous network example. Yeah, it's relatively easy, and like if you're like, well, I don't want to do it with the command line, you just go to config and you see you can set up your web routes right there, and just add them manually like this. Yeah. Any questions about web routing? No questions. I will send this file, but it's actually already in the homework section. So yeah, if you go to homework, and there is a file called lesson 2 Cyberheaven. I will copy the file. I will save the solution, by the way, so you guys get these solutions. Lesson 2 is lesson 4 now. Rip routing. There we go. I will just make sure to remove this again. You can just remove everything, making it more difficult. And we do reload on everything, so to live the configuration. Exit, reload, yes, no. Let's see. Yeah, the other ones. And just reload all the configurations. So everything is done. So you guys can try it for yourself. And if there are any questions, I would like to hear from you guys. Let's go exit. Reload. No, enter. Okay. Make sure all the computers have been nerfed. Looks good. Okay, let's save this as unfinished. Script routing. and finish. Okay. So I'm gonna share this file with you guys. Let me see where I stored it again. Oh, there we go. I will put it in the homework folder. There we go. Let's try something else now. We have done web routing, but what if we wanted to the one in the demonstration? Let's do like OSPF or something. Let's do something interesting. Do a new, and let's build it like it is in the drawing. We have like this awesome drawing that displays the network. So we have these computers here. Let's connect our awesome routers. Let's connect them up. There's a switch, okay. There we go. Believe this one doesn't have the right module. No, it doesn't. I don't think it does. So we need to turn it off and give it the serial modules. I believe. Oh, it's just. Oh, it's the console for it. Need this one probably. Yeah. And we only need one of them. Now we do it on this one too. Oh, don't forget to enable it, guys. It's enabled. Good. And we did with this one. Oh, we didn't take the exact same router. My bad. There we go. It's router 4. So we put the switch over there. Yeah, just put the switch there. And I'm gonna just give you guys this DSD assignment. I'm not gonna show you how to do it. I already showed you how to do it with rep. But it should be pretty straightforward, guys. I like to see this as a challenge. And I'm gonna share this in the as a second assignment for configuring OSPF. There we go. And then we put the serial. There we go. And then the last computer. Connect it up. There we go. Looks something similar to the picture. Quickly put all the IP addresses down. There we go. dot 1 0 slash 30. Dot 1.0. Not sure why I did it like this, but that doesn't make much sense to me. Oh, it's a slash 30, of course, then it makes sense. Six. That's 16 slash 29. One. Let's do the last two networks. Are they also 30? Yeah, they're also 30. Great. Two, 4, 2, 4, 2, 0. Okay, guys, that will be the assignment. Good luck. Let's put the things like this. There we go. And we put the text over it. Area 0. Area 1. Okay, guys, good luck. So we save this. Lesson 4. OSPF running. There you go. I'm not gonna show this one, you guys. I wanna challenge you guys. If no one is able to solve it, I will show it next week. If nobody is having questions, I think I will end this stream early. Oh yeah, you can have a slash 30, of course. Did you follow the last subnetting lessons? If you go to the IP table, you can basically see right here. Let me show you. There you go. Slash 30 will only give you 4 hosts. So if you have a slash 29, it will give you 8. So it's good to memorize this, guys. It can be useful. Yeah, for now I will send the second lesson in, or the forward lesson OSPF routing one inside the homework. If I can find it. Oh, there you go. There we go. Homework. Next week we'll go more into depth into IRGP and BGP. I think covering all of them in one lesson will be a little bit too much. So that we will do that next lesson, and then we will go more in depth into the management of Cisco devices and a few other key things. Yeah, you can see the schedule in the homework channel. Yes, those are subnet speed. That's correct. Does anyone have any more questions about this lesson? So I can answer them. You remember you used to hate teachers? Oh no. Well, I just do my best. I'm not a real teacher, but I just like to help people and get their career started. I'm trying to not overwhelm people, but I already said that I wish people would look this over yesterday already, so they can prepare for today. Um, because the material that's being, uh, I think I just copied this one. Not sure why I copied it, but I've removed this one, this slide. There you go. Makes more sense. Um, yeah, and just make sure you use the slides. Um, Tomorrow we'll go into more deep in IRGP. Yeah, I already noticed there were so little people watching my stream today. Like it started out with like 10 viewers, and I only have like 3 right now. So ERGP. We already talked about that, but it's okay. Yeah, we'll show it again. Um, it's the Enhanced Interior Gateway Routing Protocol. It's basically a routing protocol that's developed by Cisco, and it helps you choose the best route over a network. And for that, it uses algorithms. In this case, it's the dual algorithm, and it's also able to load balance over different links of the network interface and over different speeds, of course. Does that answer your question? Is there a competitor of Cisco? Many. There are many competitors, but there's no company like Cisco. I mean, you have like Huawei, you got what's the other one called? Um, I forgot the name of the other one, but let me check in Discord real quick. I read it right there, or I don't. I thought I had. But there are a lot of manufacturers of routing equipment, even open source ones. But IRGP is specifically made for Cisco. Um, yeah, Chinese copycat. Yes, that's how you could call it. Yeah, if there aren't any more questions, like, yeah, then I'm probably gonna end this stream. Also to keep under the 1 hour mark. Oh, of course. I highly recommend joining our Discord. Our slides are on the Discord. All the slides also from the previous lessons, and we're happy to have you on the next lesson as well. And yeah, I just sent you Swish tag. Yeah, no problem. Yeah, if nobody is having any questions, I will end the stream now. And I want to thank everyone. The next stream will be next Friday. I might be streaming like just some casual games or things to just relax. Maybe during the weekend or next week. It really depends how I'm feeling, actually. But you can at least expect one lesson each week. And I'm also thinking, okay, how can we expand it to different areas? But yeah, you definitely will just, if you just follow the announcements and the homework channel, you get the assignments and you know what to do. That's the most important part. So, have a wonderful day, everyone, and see you next week.